Ice cream's origins are known to reach back as far as the 2nd century BC, although no specific date of origin nor has an inventor been undisputably credited with its discovery. We know that Alexander the Great enjoyed snow and ice flavored with honey and nectar. Biblical references also show that King Solomon was fond of iced drinks during harvesting. During the Roman Empire, Nero Claudius Caesar frequently sent runners into the mountains for snow, which was then flavored with fruits and juices. Over 1,000 years later, Marco Polo returned to Italy from the Far East with a recipe that closely resembled what is now called sherbet. Historians estimate that this recipe evolved into ice cream sometime in the 16th century. Ice cream became an edible morale symbol during the Second World War. Each branch of the military tried to outdo the others in serving ice cream to its troops. In 1945, the first floating ice cream parlor was built for sailors in the Western Pacific. When the war ended and dairy product rationing was lifted, America celebrated its victory with ice cream. Americans consumed over 20 quarts of ice cream per person in 1946. In the 1940s through the 70s, ice cream production was relatively constant in the United States. As more packaged ice cream was sold through supermarkets, traditional ice cream parlors and soda fountains started to disappear. Now, specialty ice cream stores and unique restaurants that feature ice cream dishes have surged in popularity. These stores and restaurants are popular with those who remember ice cream shops and soda fountains of days past, as well as with new generation of ice cream fans. The ice cream industry globally consists of a few multinational and national firms that supply most of the ice cream in the world. Unilever, Nestlé, Häagen-Dazs, Baskin-Robbins make up about 10% of production volume and as much as 20% of the value of the industry. The ice cream industry is estimated to be valued at $73.8 billion in sales worldwide. Companies are always looking into unique techniques to differentiate their ice cream, from adding new ingredients to trying new production steps in the process.
The main ingredients of ice cream are air, water, milk fat, non-fat milk solids, sweeteners, emulsifiers, stabilizers, and flavors. The unfrozen blend of those components, except for air and flavoring materials, is called the ice cream mix. Ice cream quality can range from economic to super premium. In super premium, as few ingredients as possible are used and milk and cream are fresh, meaning it'll have a shorter shelf life. Let's take a closer look at the components of the mix and their purposes. Milk is the most important ingredient. It is water-based liquid with dissolved lactose, whey protein, some minerals, and emulsified milk fat. Milk fat is rich and full of creamy flavor. It is a carrier for any added flavors and is beneficial to melting properties. It gives ice cream body and provides sensation of a smooth texture. Non-fat milk solids are also important for the flavor and texture. Additional source is needed from concentrated or dry milk to emulsify the milk fat. It comes in a foam form to enhance the viscosity of the unfrozen phase. It stabilizes the air bubbles as well. Sweeteners give the desired taste, contribute to the texture, and have to be soluble at low temperatures. Emulsifiers and stabilizers are added to improve the body and mouthfeel. They reduce the amount of free water, leading to less crystal growth during freezing. They also hinder fat globules from coalescing. Now we can finally look at ice cream production, starting out with the blending process. First, all liquid ingredients are placed in a vat, agitated, and heated. For large batches, flow meters can be used to control amounts of proportions of ingredients added by operating pumps and valves. High ingredients can be dissolved before adding them. It is essential to maintain a constant concentration of those ingredients for each batch, as small changes in concentration can already impact the production process and alter the end product significantly. Alternatively, they can be added during agitation and heating, but before the temperature reaches 50 degrees C. This is done for skim or whole milk, powder, dry whey, dried eggs, cocoa, sugar, and stabilizers. Finally, coloring and flavoring materials are added after the mix has been frozen.
Pasteurization was developed by Louis Pasteur and was intended for the destruction of bacteria and pathogen in foods. In ice cream production, it is a biological control point. Once the ice cream mix is ready, it is heated in a container at 69 Celsius for 30 minutes or 80 Celsius for 25 seconds, according to Ontario requirements. The heat treatment must be severe enough in order to ensure a maximum bacterial count of 100,000 per gram. There are two methods: batch pasteurization and continuous process. Batch was the original method in ice cream production and is done by heating the mix in a jacketed batch setup done in small batches. The continuous process of pasteurization is preferred due to its higher energy efficiency. High temperature, short time heat exchanger (HTST) are frequently used in ice cream production. However, others exist, such as higher heat, shorter time (HHST) and ultra high temperature (UHT) heat exchangers. Once the mix is pasteurized, it then enters homogenization. This step helps ensure proper mixing and forming of the fat structure. The mix enters a piston-like pump through a small orifice, causing the fat globules in the mix to experience a sudden drop in pressure and high rate of flow. In the unstable environment, the globules are disrupted and reduced in size and chance of the fat clumping. After homogenization, the mix is then aged overnight at below 5 Celsius. This allows the mix to cool down before freezing, allowing the milk fat to partially crystallize and giving time for the protein stabilizers to hydrate.
In the ice cream manufacturing process, freezing can be considered one of the most important steps, since the quality, taste, and yield of the finished product will depend on proper freezing. Freezing is split up into two steps: dynamic freezing, where the ice crystals are formed, and static freezing, where the crystals grow larger. In the dynamic freezing step, a cooled and flavored ice cream mix enters a freezer barrel, typically cylindrical, and is then chilled with a liquid refrigerant such as vaporizing ammonia or Freon. The barrel contains a rotating shaft, dasher, as well as scraper blades which scrape a layer of ice from the cylinder wall. This type of freezer is called a scraped surface freezer. The scraper blades remove the slush of ice crystals from the walls, and then the dasher can break apart these ice flocks so that the warm liquid can melt them into disc-shaped crystals. The goal is to have the ice crystals less than 50 micrometers in diameter to prevent a grainy texture. But ideally, to have a more creamy ice cream, the ice crystals should be between 10 to 20 micrometers in diameter. Therefore, it is important to understand the crystallization mechanism, and it can essentially be broken down to 4 steps: supercooling, nucleation, growth, and recrystallization. Before crystallization can begin, the temperature of the liquid mix must be subcooled to below freezing point. The number of moles present, as well as the size of the crystal, can affect the freezing point. At a certain level of supercooling, the ice-like clusters gain enough molecules of water that they have an equal chance of surviving or not as crystal nuclei. This is called the critical radius, and then the supercooling can then transition into nucleation. Nucleation is the birth of a crystal. In a scraped surface freezer, this will only occur at the wall of the freezer where the temperature gradient is high enough to form new crystals. Nucleation starts when a cluster of ice loses energy and the molecules become more ordered such that a lattice structure can begin to form. When the cluster becomes large enough and overcomes the energy barrier to nucleation to be in thermodynamic equilibrium with the solution, it becomes a nucleus. After ice nucleates in the freezer, it must grow to become more disc-shaped. Growth of crystals relies on the diffusion of water towards the growing crystal surface, whereas solutes must diffuse away from the surface. Generally, slow freezing causes fewer nuclei to form per a given volume and time, meaning that it will leave more space for each crystal to grow larger. Quick freezing, on the other hand, results in a fast nucleation rate and therefore a larger number of small crystals, leading to less growth ability. Dendrites may also be formed during the growth phase. These are highly branched crystals and are generally unfavorable. Recrystallization is the final stage of crystallization that involves the change in shape and size of the individual crystals while keeping the total crystal mass constant. This occurs during both the initial dynamic freezing and the later hardening storage. There are 3 main types of recrystallization processes. Isomass recrystallization refers to the change in shape of a crystal without a change in mass. Migratory recrystallization describes large crystals growing at the expense of small crystals. Accretive recrystallization is when 2 or more crystals join together to form one crystal. The dendrites during recrystallization are eliminated by the time ice cream exits the freezer. As the dendrite coarsens, the branches separate and the thinnest branches melt away. The process of crystallization is determined by many factors that can interact with each other. These include the residence time, formulation, sugar content, fat content, presence of stabilizers, as well as the presence of emulsifiers. During the static freezing step, the ice cream is sent off from the scraped surface freezer to be packaged. Once packaged, it is sent to the storage freezer or tunnel for the ice cream to reach an internal core temperature of at least -18 degrees Celsius within 4 hours. It is important for the freezing to be rapid to prevent the overgrowth of crystals, as well as not stacking the ice cream so that it can prevent the deformation of the packaging. Once this is done, ice cream can be sold and distributed. The end.